Well, now we are at the SPSS, and well, now let's perform the Spearman-rho correlation. But of course, first there are some things we have to fix in the variable view first. Or well, I fixed it already, but um, it's it's uh it's important that we do this step by step. So right here I have inputted the data shown. So we have one. This is the student ranking, or not the ranking, but the students. Only using number to represent them. No need for names. So we have student 1, 2, 3, 4, 5, 6, 7, 8, 9, and student 10. And then we have their study time listed right here. 3 hours, 2 hours, 4 hours, 1 hour, 5 hours, 3 hours, 2 hours, 5 hours, 4 hours, and 1 hour. And right here, we have their performance. So student number 1 has a 7 in performance. Student number 2 has a 5 in performance. 3 a 6, 4 a 1, 5 an 8, 6 a 4, 7 a 3, 8 a 10, 9 a 9, and 10 a 2. So that's their performance levels. So input the numbers in the data view first. And now, after we have inputted the numbers, let's move on to the variable view. So for the variable view, we have to input the variable or the many variables first. So here we have to input the title here, or the title of each data set. So we have here students. They should have an S. That's a plural. So we have students here. So once again, these are the students. Variable. In variable view again, we have study time, and then their performance in number 3, right here. And now change the measurement. Very important to change the measurement. If you don't change the measurement to its right form of measurement, you're getting nothing. So we have students at nominal here. We have study time at scale. Scale is ratio or interval, but in SPSS it's inputted as scale, and performance is scale as well. Now study time you could put as ordinal, but we'll go back to that later. There's a reason why I put scale first, but realistically that could be interval. So how do we do the Spearman-rho? Well, so first, so after inputting all the necessary data and making all the necessary adjustments, the variable view is all well and done. So go to data view, go to analyze, and go to correlate, go to bivariate, and now we have this. So what do we do with this? Well, first you're putting the variables right here. We put study time and we put performance. Now what determines a variable? Well, any number that could be changed or affected, that becomes our variable. Students, so this stays here because, like I said, that number cannot be changed. Those numbers here, right here, only used to represent the students, not a ranking in any way. But that is used. But this is just the names of our students. Rather, we're using numbers to represent them. Now that we inputted the study time and performance here, click options. Um, do anything that you wish to do so. For example, we'll put means and standard deviations here. Why not? Now, pick Spearman in the correlations coefficients. Uncheck Pearson. Only pick Spearman here. Two-tailed, one-tailed. We'll be doing two-tailed first. And now click OK. And here we have our results. So here's our correlation. We have Spearman-rho, and as you can see here, these are the numbers. You could read them. Let's read them. And as for our result, we have correlation is significant to the 0.01 level two-tailed. That means there is quite a significant relationship between our variables. And that's pretty much it. You might think it's simple, and well, it's simple, but I wouldn't call it easy. Those are two different things. But it's a bit too short. So let's try to experiment with this data set some more. Yes. So let's do it again. Correlate by variate. We'll be doing a one-tailed test now, and let's see the results. Now, this is the one-tailed test we have here. As you can see, numbers didn't change at all, and the correlation is stated to still have a significant relation at 0.01 level, but in a one-tailed test. So, very impressive, still very impressive results. Going back again. Let's do some more, experiment with it some more. Let's do, alright, actually, let's go back to variable view now. So, like I said earlier, this could be ordinal. So, let's put ordinal here. Going back to correlate and bivariate. Reset. And put study time and performance here. Spearman. Don't forget. And you see here, yeah, you can't, it's blocked out. You can't press it. Because of the way the variables are set here. It's only open in a specific factor or form. So we'll be doing a two-tailed test again. This time we have study time as ordinal, or yes, ordinal. And you can see the numbers still haven't changed much, but still very significant results we have here. Yes, nothing changed. Haven't changed much. Correlation is still significant at the 0.01 level, two-tailed, but we have study time in the ordinal scale. So let's go for one more. Correlate by variate. This time we'll be doing a one-tailed. See if we can do this now. Not yet, but let's exclude cases list-wise this time. And here are our results. Got shorter, but numbers are still pretty much the same. Spearman-rho, study time, so 1, 911, and well, the correlation is still significant at the 0.01 level at a one-tailed test. And yes, that's it. This is pretty much our data here. As you can see, we've experimented with the couple of differences in the settings. We did a one-tailed and two-tailed test, but in all the results that came out, it's still a significant level at the 0.01 level. So yes, that's how you do a Spearman-rho hypothesis test at the SPSS. So remember, analyze, correlate, bivariate, and this. Remember, the variables are numbers or data that can be altered. And that's pretty much it. You might think it's easy. Well, I wouldn't call it easy. I would say simple. Those are two different things. It seems simple, but it's not easy. There are many, many ways to make mistakes here when operating the SPSS. It is not easy, but it is rather simple when you know how to operate, or you at least have some familiarity with operating the SPSS. Now, me, I will tell you honestly, I have very little knowledge with the SPSS, and I'm learning what I can here. I understand the basics, but still a lot to learn. So I implore you, to whoever you are watching, that you learn the SPSS. You you operate it to its fullest potential. You watch many tutorials on the internet or any articles. Learn the SPSS and use it to its fullest potential, really. This could help you a lot, especially in schoolwork, even in office work. It just helps a lot.
Let's now move on how to solve Pearson R manually. First, what is Pearson correlation? Pearson correlation coefficient is a statistical measure that describes the strength and direction of linear relationship between two variables. It is commonly it is commonly used in statistics and data analysis to assess how closely two variables are connected. Now, let's proceed with the given problem that we will solve and able to understand how to solve Pearson R. Statement problem A. A researcher wants to investigate relationship between students' hours of sleep the night before an exam and their exam scores. The researcher collected data from 8 students, recording the number of hours they slept and their scores out of 100 in the exam. The aim is to determine whether there is a linear relationship between sleep duration and exam performance using Pearson correlation coefficient. In order to solve this problem, we need to get the variables. X is the hours of sleep, Y as the exam scores. Next is to collect the data, and next is to use Pearson R formula to solve. Here we can see R is equals to N times XY minus X times Y over the square root of N times X squared minus X squared times N times Y squared minus Y squared. So let us look at the table. The table shows the numbers of hours of sleep and the exam scores. In order to get the X, all we need to do is to add them together, which is 48. And just like the X, we also need to add the exam scores in order to get the Y, which is 564. Now, how to get the X squared, Y squared, and XY? First, since it's X squared, all we need to do is to multiply the given number. So 6 squared is 36, 5 squared is 25, 8 squared is 64, 7 squared is 49, 4 squared is 16, 6 squared is 36, 5 squared is 25, and 7 squared is 49. Same procedure with Y squared. Just multiply the exam score in squared and you'll get the answer, which are 5,625, 3,600, 7,396, 6,400, 2,500, 4,900, 4,225, and 6,084. Now, how to get the XY? We simply multiply the X and Y. We simply multiply X and Y. So first is 6 times 75 is 450. 5 times 60 is 300. 8 times 85